Two graphing. So let's take a look at a couple. Okay, got a piecewise here and a sine function. Sine's pretty easy to graph. Basically what you're going to do is you're going to make a big long number line. You're going to number it from negative 2 pi to 2 pi. Now the only thing we're interested in only the quadrantals. And the biggest sign could be as 1, the smallest thing could be as negative 1. And the quadrantals, of course, you got pi, then you have pi over 2, 3 pi over 2. And of course they go backwards. Negative pi over 2, negative 3 pi over 2. If you know the quadrantals, it's pretty easy to do. Sine of 0, and I'm going to use my hand. Sine of 0, there's no fingers below it, so it's 0. Sine of pi over 2, there's my pi over 2. Count the fingers, square root of 4 over 2 is 1. So at pi over 2 it's 1, and then it just repeats itself. We kind of know the pattern. So it's, and going backwards, it's just the opposite. Negative, 0, up, down. And there's your graph. So if you know the values, the sine of pi is 0, the sine of 3 pi over 2, negative 1, sine of 2 pi is 0. So in backwards, we just kind of flip it around. Sine negative pi over 2, negative 1, sine of negative pi, 0. Sine of negative 3 pi over 2, that's really the same as pi over 2, is 1. And we can graph it. Remember, it's curvy, makes a wave. Whoa, whoa, whoa. And there's our graph. Sinusoidal. All right. Now, to graph number 12, it's a little bit harder to do. There's kind of an interesting little thing right here. If I graph it, I have three parts here. I have y equals negative 1 for x is less than or equal to negative 1. Then I have the line y equals 3x plus 2 for everything. Now, this is kind of an interesting way to write this one, so let's talk about how to do this. It's absolute value. So, of course, you can get x is less than 1. But remember, you're also going to switch it. Or x is greater than negative 1. Like so. Absolute value could be positive 1 or negative 1. When you make the negative, you switch it. So I could write this as between negative 1 and 1. And then my last function, y equals 7 minus 2x for x is greater than or equal to 1. So when I graph this now, very easy to do. Here's negative 1. Here's 1. It's at negative 1 here. Can include it. Always. And a quick way to do this one right here, if it's greater than 1, plug in 1. Let x be 1. If I let x equal 1 here, y is, what is that? 7 minus 2, 5. So at 1, up 5. There it is. Can include it. Now, I'm not looking for anything in particular here, but the slope here is negative, so it's going down pretty steeply because it's negative 2. What happens in between here? Well, what shape is that? That's a line. Now, if you want to, you can look at the endpoints. If x is negative 1, y is, what is that, negative 1? It's negative 1. Oh, there it is. If x is positive 1, my y is 5. So there's my 2 points when I connect the two. And there's my graph. Now, of course, can I get the domain here? Yep, the domain, very simple. It goes from negative infinity to infinity. My range, be careful, the biggest it's going to be is 5. But it keeps going down to negative infinity. So I start with the negative infinity, and it goes to 5. It can't include 5, so that's a hard bracket. Very easy to do. Now, if I want to get the Y-intercept, remember, that's where x is 0. Well, where x is 0, let's take a look here. I'm going to be on the second function. So it's y equals 3 times 0 plus 2, and it's 2. So it's 0, 2. If I want to get the x-intercept, it's where y is 0. Now, for that one, I might look at the graph. Where y is 0, it looks like I'm on that first line right there, that second line again. So I'm going to use the line y equals 3x plus 2. I'm going to use this one because of where it's located. It's located in the middle of my line, so I'm going to use my middle function. So 0 equals 3x plus 2. X looks like it's negative 2/3. And there's your x-intercept. All right, so take a look at these, try them, practice them. You'll see these on your test on Wednesday or Friday, depending if you're BC or AB. See you then. Bye.